Welcome to this presentation on the Master's Program in Technology, Work, and Health. My name is Catherine Trask, and my co-presenter is Miko Foshman. We both work at the Division of Ergonomics at the CBH School at KTH. I'd like to start out by telling you a little bit about the global skills gap and the global need for work environment engineers. The International Labour Organization, or ILO, tells us that workplace illnesses and injuries are a very common and expensive worldwide problem. Often these illnesses and injuries are related to hazards in the work environment. The good news is that improving the work environment can prevent injuries and illness. And this not only improves the health of the workforce, but also the long-term sustainability of the workforce and its productivity. So the global need for work environment engineers is a worldwide phenomenon, but it's also the case in Sweden. There's very high demand for this occupation, and when new jobs are posted, there's often little competition, even for new graduates. As a specific example, the Swedish Work Environment Authority, or Arbetsmiljöverket, has set a recruitment goal to employ 300 inspectors by the year 2030. Professionals in this field have their choice of employers in both the private and the public sectors. If you select a career in ergonomics and work environment engineering, you can anticipate having a fast-paced and dynamic working life, meeting new people, learning about new technology as it arises in industry, learning about the hazards that new technology may bring with it, and then developing and implementing solutions to prevent those hazards from resulting in ill health. Ergonomists and work environment engineers actively influence and manage change at the worksite. And in doing so, they make a difference in the health of the workforce, in the economic productivity of the corporations and organizations that they work with, and in general for people, companies, and society. Careers in work environment and ergonomics do require specialized training, and that's why we have the International Master's Program in Technology, Work, and Health. This QR code will bring you to our website. I'll also tell you a bit more about the program now. The ergonomics program education takes place at the KTH Flemingsberg campus, just south of Stockholm. As you can see, this is a really large and modern campus, and it's also situated in the middle of some very nice nature. This photo shows the construction of our building as if they were putting on the finishing touches. So this nice new modern building is where all the labs and lectures take place for our program. Our program takes as its basis the HTO model, that's human, organization, and technology, and looking at the interplay between these facets. Our goal is for sustainable work and organizational performance. So finding a combination of human health and wellness and overall system performance. Graduates of our program learn to analyze work environments with respect to physical, chemical, cognitive, and organizational hazards that could contribute to illness or injury. After analyzing these hazards, our graduates learn to design and implement solutions that will mitigate ill health effects. Graduates learn occupational safety and health management, as well as leadership for organizational change in an occupational safety and health context. Our program provides a balance between theoretical knowledge gained through lectures and readings, and also practical and applied experience through group project work and the master's thesis project, where students are encouraged to go out into real workplaces and to encounter and consult with real workers, employers, leaders in union, and other occupational health and safety professionals. And in this way, they get to apply the theoretical knowledge that they gained in class. The Ergonomics Department of KTH is a research-driven environment. Our team of faculty are highly productive researchers with international reputations, and they consistently contribute to the scientific literature in this field. There are many ongoing funded projects in the department, and these projects tend to be applied projects that address real-world challenges. This is great because it gives students the opportunity to get involved in funded research as a part of their master's thesis. And then they can get involved in projects that address real-world challenges and also leverage the partnerships that we have with companies in the public and private sector. I'll give you a few examples of research projects happening at the Ergonomics Department. This first example is the Observational Methods Project. Several professional ergonomists were asked to look at different work tasks and then asked to rate the risk for musculoskeletal disorders. So this picture as an example, this meat cutting task, ergonomists were asked, what is the risk for right shoulder disorder in this job? Low, moderate, or high? Green, yellow, or red? We see that when they aren't given a systematic approach or a tool in order to assess a task, ergonomists can deliver very different risk ratings. Some say low, some moderate, some high. This is true not only for the shoulder, but for all different body parts, and not only for the meat cutting task, but for lots of different kinds of tasks. Ergonomists have very diverse risk ratings when they're observing tasks without a systematic approach. This leads us to the notion that it would be very helpful to have higher resolution, more technical direct measurements of body movements and the type of biomechanical exposures that could lead to musculoskeletal disorders. And that brings us to the next project of Ergo Arm Meter. This project asked, can a mobile phone identify shoulder injury risk? And here we see a mobile phone in a strap attached to someone's upper arm. And so in this research project, the team used the intrinsic accelerometers of the smartphone and developed an app that can, with high resolution and high precision, quantify the positions, the speed of movement, and the repetition of the upper arm. There are lots of jobs out there that have risk for shoulder injury. These pictures show workers in the construction industry. If we wanted to learn more about their arm positions and the risk for shoulder injury, we could bring them into a biomechanics lab and use specialized sensors, light reflecting joint markers in order to see how they are moving. This is a very expensive approach, and it also loses the context that we find in working life. Simulated tasks in the lab are just not the same as being out in a real work site. So the research at KTH Ergonomics Department developed smart clothes that have small portable data logging sensors that can be tucked into little pockets in the clothes and allow the workers to move around, do their jobs as usual at their work site, all the while being measured in a high resolution, highly precise way. This means that for a much lower cost, we're able to measure real workers doing their real tasks in a real workplace context. And that gives us far better information for research, also for solving the problems at the workplace. Those are just a few examples of research projects happening in our department. Now I'd like to tell you a little bit more about our contributions to the United Nations Sustainability Goals. The Masters in Technology, Work and Health and our department contribute to 3 UN sustainability goals. The first being number 3, good health and well-being, by reducing illness and injury and improving worker health. The second UN sustainability goal is number 8, decent work and economic growth. And we do this by fostering fair workplaces that are compliant with occupational health and safety guidelines. And this leads to workforce sustainability so that workers can stay healthy and productive throughout their working lives. The third UN sustainability goal is number 9, industry, innovation, and infrastructure. Here we are enhancing productivity and quality of the work, and ergonomists and work environment engineers contribute to innovating new solutions at the workplace, solutions that enhance the work environment, but also enhance productivity and quality.